Okay, example 7. Usually after those first 3 examples, I'd say at least probably half the kids are usually starting to get it. Obviously, it's hard for me to tell online like this of where you're picking it up at. So let's do a few more examples, because usually a lot of the kids are saying, okay, I'm good to go, Mr. Dresch, leave me alone. But let's do a few more here. 5 root 10. Let's take that 10. 2 and 5. Those are primes. Prime factorization of 10 is 2 and 5. And then, as I said, a lot of kids are like, okay, I'm good to go. But then we run into something a little tricky like this, because there is no pairs. Pairs make perfect squares. I don't have that. I have a single 2 and I have a single 5. So what that means is 10 is already simplified. Just like if you ended up with a third and a fraction, you couldn't simplify 1/3 anymore. It's the same kind of idea. 5 root 10 is already simplified. So don't freak out if you didn't end up with any pairs. It doesn't mean you did anything wrong. It just means it was already simplified. Then to 25. 3 square root 25. 25 we know is 5 and 5. So the prime factorization of 25 is 5 times 5. Pairs make perfect squares. And this next example I throw out there each year is because I usually have students give me 1 or 2 answers. One answer students usually say is 15, and the other answer is 3 root 5. Those are the 2 most common answers I see. One's right, one's wrong. Well, let's think about this. Pairs make perfect squares. 5 times 5 is 25. And square root 25 is 5. It is perfect. There's nothing left underneath the radical. So 3 times 5 is 15. That is the correct answer. But I always have students want to keep a square root sign there on a perfect square. You kind of get in this mode of got to have a square root. This is not the case. So this is incorrect. Okay. That's the common mistake I see a lot of times. So those are the things to watch out for when we go back to 25 with a perfect square. Okay. So let's look at the next one then. Now that 96 gets a little bit larger there. So it ends in a 6. It's in an even number. So something gives you 96. 2 and 48. What is that? 3 and 16. 4 and 4. 2, 2, 2, 2. Sorry for the mess there. Okay, how many 2s I end up with? 5 and a 3. Pairs make perfect squares. I have 2 pairs. For every pair, 1 number comes out because it's perfect. Square root of 2 times 2 is 4. Square root of 4 is 2. Square root of 4 is 2. And 2 and 3 were loans. They're left over. So let's see what we got. Negative 24. Square root of 6. Okay, the next 2 examples, 10, 11, you try it on your own. I'm going to just put an answer there, but I will not make a video for that.